All right, we're either at the last video or maybe the last of two videos to go through the two questions on the practice test that will reflect the kind of hypothesis testing that you're going to have to do and show your work for test 4. So it says in question 17, a researcher wants to determine whether there is a difference between two sunscreen lotions. Participants in a marathon race on a hot sunny day applied lotion A on one arm and lotion B on the other arm. The results are shown in the table. So if you're looking for how to do questions like this, you want to look between pages 607 to 610 in your book to look for the procedure on this. So again, there is a procedure for what we're doing here. What we're going to do for this is we're going to go through and basically create a null and alternate hypothesis like we usually do. So for the null hypothesis, and it's going to be the same type of null and alternate hypothesis in pretty much every situation. So we're going to see here for the null hypothesis, the proportions between the two populations are equal. Sorry guys, just realized I'm kind of off the chart here. There you go. So for that question, again, refer to page 607 to 610. That's going to be our null hypothesis. The proportions between the two populations are equal. And then for the alternate hypothesis, and by the way, this should not be a equal sign, should be a colon here. The proportions between the two populations differ. And in this case, so the researcher wants to determine whether there is a difference between two sunscreen lotions. Okay, so we have our null, we have our alternate. The significance, the level of significance is alpha is going to be equal to 0.05, pretty standard one. To calculate the test statistic, and in this case here, we're going to have the test statistic. To calculate that is going to be chi squared of 0 equals to the absolute value of f12 minus f21 squared divided by f12 plus f21. Now f12 and f21, this is a way of coding it here. Like for example here, this would be f11, this would be f12, this is f21, this is f22. Again, you probably should have read the book by that, and hopefully you know that. So know that the values I'm going to be focusing on to come up with the test statistic are going to be f12 here, and then f21 here. So this is going to work out to be the quantity of 40 minus 50 squared divided by 40 plus 50. And if you put that on your calculator, that's going to yield a value of 1.111. We want to make the comparison of that to the degrees of freedom, which is, or we get by finite degrees of freedom. So we have, for this, the degrees of freedom in this situation is always going to equal 1, and the level of significance is going to be 0.05. So what we're going to look at here is from the table, we're going to find the critical value we require here. So we're going to look at degrees of freedom here. We're going to look at 0.05. So we're making this comparison of 3.841. So from here, we get the critical value equal to 3 point from the table, 3.841. Now, if you're looking at this, and this is 1.11, the critical value is 3.841. The test statistic has to exceed the critical value. So if the test statistic does not exceed the critical value, we do not reject HO. So hang on one second. Yeah, this is the notation I'm looking for here. So here is, so when we make the comparison here, when we're calculating this, okay, if we're going to reject the null hypothesis, then it's the case that the critical value has to be greater than the test statistic. If this is true, if true, reject. If not true, fail to reject. But in this case here, what we have is our critical, oh sorry, I got these reversed. If our test statistic is greater than our critical value. So if our test statistic is greater than our critical value, then we reject, otherwise we don't. So in this case here, our test statistic is 1.111. Our critical value is 3.841. And because our test statistic is less than the critical value, we're going to fail to reject this. So, and as it says in the answer key, for this particular question, there is not sufficient evidence, okay, is not sufficient evidence at the alpha equals 0.05 level of significance to conclude, well, you can read it because it's the answer, to conclude that there is a difference in the effectiveness of the two lotions in preventing sunburn. So you may think that's the case, but there's, from a statistical standpoint, there is not sufficient evidence to make that conclusion. So therefore, we will reject the null hypothesis. I'll let you get the rest of the statement there from your from the solution there. Let's go ahead and work out the second problem that requires work on this one. So it says 4 different types of insecticides are used on strawberry plants. The number of strawberries on each randomly selected plant is given below. Test the hypothesis that the type of insecticide makes no difference in the mean number of strawberries per plant. So remember that when you're doing ANOVA, you're usually going to work with 3 or more means when comparing. And at this level of ANOVA that you're studying, you're not going to be able to necessarily conclude which one is significant. If there's a significant difference in the means between one or the other, you're just going to be able to conclude whether none of them have a significant difference or if at least one of them has a significant difference. So when we're preparing the statements for this one, make sure that this is visible on the screen. Yeah, the first thing you want to do is you want to say for the null hypothesis that mu1 is equal to mu2 is equal to mu3 is equal to mu4, which where the claim is focusing on here. And the alternate hypothesis, and by the way, the claim for this are generally going to be the same. They don't differ, not at least for this type of test. At least one population mean is different from the others. And this is going to be section 13.1 of the book, which you can look at. The level of significance in this question for alpha is going to be 0.01. And what we're going to do is we're going to type this information into the calculator. So let's go to Stat, go to Edit, and let's try editing the list this time. Let's clear it out. And let me try to type it in accurately this time. 6, 7, 6, 5, 7, 6, 5, 8, 5, 5, 5, 6, 6, 3, 2, 3, 4, 3, some days, folks, is just not your day. Try that one more time. 6, 7, 6, 5, 7, 6. Oops. All right. 5. Yeah, we have to do this when you're making a video. It can be a little challenging to try to do two things at once. So my apologies for the technical difficulties here. 3, 4, 3. And finally this 4. 3, 5, 3, 4, 5, 4. All right, I think I have everything. I'll just take a quick look, make sure everything typed in. 5, 8, 5, 5, 6, 6, 3, 2, 3, 4, 3, 3, 5, 3, 4, 5, 4. That looks good. 6, 7, 6, 5, 7, 6. Okay, should be right. So again, I'm going to go to Stat now. I'm going to go to ANOVA. And I'm going to type in second L1, comma, second L2, comma, second L3, comma, second L4. Close. Oops, I think I typed in L1 there. There you go. And then hit Enter. Okay. And for this one, we're going to do a comparison of P. At least this is how I'm going to do it. I'm going to compare the p-value. I'm going to compare that against alpha, and I have p is equal to 8.457 times, it says e to the minus 4, which is like scientific notation, so I would write this as like 8.457 times 10 to the negative 4. So for this one, you want to show the work that you do in the calculator if you can use ANOVA, which is just going to be L1, comma, L2, comma, L3, comma, L4. And believe me, it's a lot easier doing it with the calculator than it is doing it without. Let me push this up a little bit here. And we're going to find the p-value is going to equal 8.4, so it's going to be 8.457. But instead of using engineering notation, you use scientific notation. That's going to be 10 to the minus 4. So for the last part here, for 4, not for the last part, but you want to say is p less than alpha. So if you were to write that out as a decimal, you don't have to. You could write this out if you want, but I'll just write it as 0.000847. Is that less than 0.05? Absolutely. That's true. Therefore, we're going to go ahead and reject the null hypothesis in this case. Push it up a little more. So we reject. And then finally, we're going to say that this data provides ample evidence that the sample means are unequal. Okay, so yeah, the sample means are going to be unequal to each other because that's what we're going to do. We're rejecting the null here in this one. Okay, and you can refer to the answer that's on the answer sheet for this. So I apologize for all the technical difficulties in the video today. And if I had an opportunity to clean these up, I certainly would. I hope nonetheless that you find these beneficial, and perhaps some of the things that you saw me experience are likely some of the things that you're likely to encounter unless you get some practice in as well. I wish everyone good luck.